Good. Here we go. Okay. So on this one right here, notice it says 0.5%. What's another way to read 0.5? Half or 5/10, right? So 0.5 or 0.5 is slang. Properly, it's 5/10 or reduced down, like Colt said, you could call it a half. So recognizing that's 0.5%, what I would do here is, missing my notebook, I would take the $14.95 and just call it 15. So I have about $15 to work with. And instead of thinking about 0.5%, so I have the 0.5%, which you could call 0.5%, I'm just going to round it up and just call it 1% for a minute, because 1% is not too bad to deal with. So what's percent mean again?
Divide by 100.
Divide by 100, right? So that's 1 out of 100, or basically 1 cent for every dollar is what you could think about that as. Okay. So how many dollars do I have here? 15. So 1% would be 15 cents. Does that make sense? Because 1% would be 1 cent for every dollar. Okay. So then my guess is that 1% of that would be 15 cents. So $0.15.
When you do 100 times 0.05.
What's that? Well, I'm just trying to estimate it. So I'm trying not to do any calculations really. I'm just kind of guessing around at it.
Oh.
Okay, so we're trying to avoid using a calculator. It's usually what approximate means.
Oh, I thought it just meant like round them, so like the other ones.
So rounding is definitely some way you could do it. So when I was talking about this last Wednesday, I think I talked about this. I said just kind of look at it and try and find ways to look at the numbers, make them easier, and then make a guess at what the answer is. Rounding is definitely a way of approximation, so you could totally do that. So that's one reason I could say, if you were going to round 0.5% to the nearest whole percent, what would you call it? Come on, someone help me out here. Elizabeth, you would call it? 1%. Yeah, that's the nearest whole percent, 1%. So I could round and say, yeah, it's 1%. Then I just got to figure out how to take 1% of $15. Okay, so you could say, hey, 15 cents is one possible answer here. Okay, but Colt said, wait a minute, 0.5 is a half, so what would be about half of 15 cents? 7 cents, 8 cents, something like that. Yeah, so here's one estimation right there. Another one would be cut that in half, right? And you could call it 7 cents or 8 cents. That would be another possible guess at this. Okay, or you can just whip out your calculator, type 1% of 15, and it's going to give you 0.15. So that'd be another way to go about it. So what's that?
I did those ones wrong.
No, you didn't do them wrong. It's just the point here is just to come up with different ways to approximate. And when I mentioned on last Wednesday, I said try to do it without a calculator. Right, but there's nothing wrong with using a calculator.
But the opposite side too, like I could think of one that I could do.
Yeah, and I also said if you can only come up with one way, that's fine. No big deal. I'm looking for at least one way. Yeah. If you can come up with two, awesome. So I got two different ways. One way I say, yeah, it's about 1%. 1% of $15 is about 15 cents. So there's one possible estimate. And then I could think like what Colt said, yeah, just cut it in half. And if I cut it in half, I'd probably call it 8 cents. That's probably what I'd go with. Because rounding, how can you give somebody a 0.5 cent? Banks would typically round it up, say, yeah, you owe me 8 cents. Note, which of these is a right answer? No, I guess that's it. Yeah, I guess I don't have a third one. Which of these is the right answer? 8 cents or $0.08?
Yeah, $0.08.
They're both right. Right? A cent is 100th, so that's 8/100ths of a dollar. So this says 8 cents, that says 8 cents, they both say 8 cents. Here I'm giving it in cents notation, here I'm giving it in dollars notation. They both mean the same thing. Okay. How would I write 1 cent in dollars? Yeah, 0.01. Okay. Yeah, so any way you came up to estimate, even if it was rounding with a calculator, that's cool too. Okay. Other questions on worksheet 8? Okay, if you need to tidy it up, do so and give it to me tomorrow. If you have any questions, you can ask me after class or catch me later. If you're done with it, you can drop it off up here on the desk or submit it online. Oh yeah, cool, thank you, sir. This. And then if you have anything that's late, the deadline for anything in Module 1 is this Thursday. I won't take anything after this Thursday. So if maybe you skipped a prep or you didn't quite finish a homework, you have until Thursday to get it done. If you need help, track me down, please. Okay, let's see. Colt said there were some cute problems in the prep that were kind of tricky to enter in. So I'm going to take a look at that. Let's see. Prep 1.9. Number 1, not too bad. Let's see. There were, do you remember which number?
I think it was 6.
Okay, which of the expressions,
Oh, no, it was
not,
5.
it was 5? Okay, for each of the following, write an equivalent expression using the distributive property. Okay, so I didn't talk about the distributive property, but I hope that, let's see, I think there was something posted here about it, wasn't there? No?
I knew what it was.
There was supposed to be a section right here, but it is missing.
Yeah, it said it, at one point it did say refer back to something, but I don't know
Huh.
what to refer back to.
Where did it go? That is my fault. I messed something up. Oh, by the way, as you read through these, you'll occasionally come across OCE
Yeah.
and PLN. So OCE means out of class experience. And me in a class last year decided that was just too weird a name. It's really just homework. So anytime you see OCE, I forgot to edit it out. It should just be homework. PLN is preparing for the, or PNL, preparing for the next lesson. That's what we call prep now. Okay, so they used to be called PLNs instead of prep and OCE instead of homework. And I've mostly edited that abbreviation out, but apparently I missed a couple. Okay, so let's talk about the distributive property and then we'll do these here. All right, so distributive property. So the distributive property, actually, that's the short name of it. The full name is distributive property of multiplication over addition. So that's things like 2 times 3 plus 4. So here I have a multiplication, and the multiplication is happening to an addition. The addition is grouped with parentheses. To illustrate why this works the way it does, one interpretation of what multiplication means is an area, where one of these things is the base and the other number is the height. Or you could call them length and width, means the same thing. So for example, if I were to draw a rectangle that has a base of 2, probably looks more like that to make it accurate. So this is my 2, and then it has a height of 3 and 4. So there's 2 ways to think about it. If this was a floor plan for part of a house, maybe a hallway, and that hallway was segmented somehow, bottom line, the whole hallway is 7 units long. But each room in this hall is definitely 2 by whatever the other number is. Okay, so that base distributes through the whole rectangle, through the whole hallway. So there's 2 ways to look at a multiplication over an addition like this here. One is it's just use the order of operations. Order of operations says you got to do what's inside the parentheses first. 3 plus 4 is 7. 2 times 7 is 14. But the geometry of the situation gives me another way to look at it. By saying both the 3 and the 4 are being doubled here, right? They're 2 wide all the way through the rectangle. So you could also say it's 2 times 3 and it's 2 times 4. Right, so that's what the geometry of the situation gives us. 2 times 3 is 6, 2 times 4 is 8. On a good day, 4 and 8 gives us 14. So we get the same answer either way. It's just another way to look at the problem based on the geometry of multiplication. Okay, and that, what's that?
In the distributive property, like the first outer inner.
So that's distributing 2 rectangles. So you're thinking of the idea of FOIL. Anybody ever remember hearing FOIL in some previous math class? So that's when you have like a more complex floor plan. So for example, suppose we had a rectangle, let's say this shape right here, and it was broken this way into a wall coming across that makes this 3 and then 4. Oops. And let's suppose this way we come across and say this way it's 2 by 5. So by making a division both horizontally and vertically, we broke this room into 4 parts. Okay. Bottom line, the area of this whole floor plan, right, it has a base of 2 plus 5, and it has a height of 3 plus 4. Order of operations says do what's inside the parentheses first. 2 plus 5 is 7. 3 plus 4 is 7. 7 times 7 is what? 49. Okay, so bottom line area of this whole thing is 49 square units. However, we can also break it down and say, well, there's different rooms here. What's the dimensions of this room right here? 2 by 3. And this one?
3 by 5.
It's 3 by 5 or 5 by 3. Right, either way. What's this room down here? 2 by 4. And this one over here? 5 by 4. So I have a bunch of smaller rooms that I can look at. So if I add up all those smaller rooms, we have the 2 by 3 room, which is 6. We have the 2 by 4 room, which is what, 8? And we have the 5 by 3, which is a 15 square unit room. And we have the 5 by 4, which is a 20. See if we can add those suckers up. 14 and 15 is what, 29? And another 20 is 49. And so the bottom line is this 2 had to be distributed over to the 3 and the 4, and that's what we see happening right there.
Is that what you would do on the ones that there's a homework?
Would have variables in them?
Like on 1.8, like where you have the 2 shapes.
Let me look back at that. I'm not sure. That was in the 1.8 homework? Okay, we'll take a look. And then here the 5 has to distribute to the 3 and the 4. Oops, I need to switch colors. To the 3 and the 4, and that gives us this part of the building right there. Okay, and that's an idea when we have a 2 by 2 system like that. They often call that foiling. Okay, and FOIL stands for you have to multiply the first terms together. That's the 2 times 3. Then you have to multiply the outer terms together, 2 and 4 on the outside of this. Then you have to multiply the inner terms. That's the 5 times 3. That's I for inner. And then you have to multiply the last terms of each group, and that's the L. So it's called foiling. Foil. Kind of exciting, huh? All right, so I'm going to back this up a step and look at that problem we just had of 2 times 3 plus 4. So according to the distributive property, that's the same as 2 times 3 and 2 times 4. Whenever we take it in this direction right here, that's called distributing. But you can also undistribute by making a note, hey, these guys have a common factor of 2. I can pull that common factor and write it out front. When you take it and go the other direction by noticing that common factor and writing it out front, that's called factoring. Okay? So taking the distributive property backwards is factoring. The reason I mention that, because sometimes it's helpful to go the other way. It depends on the problem.
It'd always be helpful to go. It seems like it'd be simpler to do it
This way?
No,
Or take it back that way?
so it's just 2 times whatever that number is.
So,
I mean, where does that come in handy? I mean, is it for bigger numbers, or why would you want to take it out of the top to put it in the bottom? Scenario.
why bother doing that?
Yeah, why? I mean, what scenario makes that better or easier?
Um,
That's all I'm wondering. I can see where it would be easier if you could take the bottom and put it in the top because it might be simpler and quicker.
yeah. So, man, I don't think I have a good answer for that.
Or is
So
this
first thing that
something you
comes
should
to
know?
mind is like the perimeter of a rectangle is twice the length plus twice the width, and that's the common way of viewing that formula. But you could also view it as 2 times, if you consider the idea of factoring, the length plus the width. So there might be some scenarios where it benefits you to add those guys up before you multiply.
Yeah.
And the main thing I can see that coming in isn't this formula right here, but think about sales tax. I grew up in Rhode Island, and sales tax there is 7%. So every time you buy something, they charge you an extra 7% on it, right? So if I go into a store and I buy a bunch of things, so I buy something for $10, I buy something else for $8, I buy something else for $15, and so on. One way to think about that problem is I have to take 7% of each of those times 0.07 times 0.07. And then I can calculate each of those. So let's see, 7% of $10 is what, 70 cents or 7 cents? It would be 70 cents. And this would be what, 56 cents? Oops, that's supposed to be a plus. Am I doing this right, you guys? Robert put me on the spot, now I'm nervous. And then let's see, that would be $1.05. I need a calculator. 95?
Well, the first one is.
Let's see, 70 and 35 is 105. So I think that's going to be $1.05. I could be wrong, so somebody better check that for me. All right, and then we add all those things up. So, that's a fair amount of work. Sometimes it would be better, and think about the way cash registers work. They add all of that up before they apply the tax. So what they would do is they would say, hey, that's 10 plus 8 plus 15, and that's what we take the 7% of. Because it's easier to add first, then multiply. It's less work that way. Okay, so it just kind of depends. Sometimes one way is better than the other. I'll think about that some more and try to come up with a better answer for you tomorrow. That's the best I got at the moment.
I was just wondering why. I understand that we should know that that's the way it works, is we can do it the other way, but what would make us want to do it that way? Circumstances. So I will show some other circumstances, yeah. So when we get into the spreadsheet, I'll come up with a couple ways to look at it there. All right. Okay. So let's see, coming back here to that problem, rewriting this, it says do not actually evaluate. And so that's what gave Colt fits when he was working on this, because, typing it right. So the way to not evaluate it would mean to just call it 4 times 3, don't call it 12. And this right here would be 4 times 6, don't call it 24, just leave it like that. We just want to rewrite the first stage of the distributive property. Okay. Down here, I have to distribute the 12, and keep in mind, in algebra, there's really not much of a difference between addition and subtraction. There's similar operations, so you can distribute over subtraction too. So this would be 12 times 8 minus 12 times 2. Now here, it's already distributed, so what should we do? We should undistribute it. So what's common as a factor in part C here? Yeah, so we pull the 100 out, then we go parentheses 5 plus 4. There it is. To undistribute that. So that'd be the way to write it with the distributive property working backwards. Okay, so just kind of getting used to. There's 2 different ways to do it. Sometimes one's better than the other. Let's see if I get it right. Oh, what? Oh, it probably wants a multiplication symbol there. I bet that's it. Let's see.
I don't think it ended up being.
Ah, it still doesn't like it.
It's 14.
Oh, it's a 14. I can't read. I probably don't need the times symbol. Submit again. Ah, get it right that time. Okay, and I think the times is probably optional. I bet I can
to see a new one. Let's see, how do I get a new one? There, we try a similar. Okay. So if I pull out the 100, I could also do times, parentheses, 5 plus 14, not 4. Submit. I know I didn't do the other parts. Yep, okay. So it doesn't matter whether you put the times in there or not. Notice that I can get by with or without it here. But up here, I have to put it, because otherwise 4, 3 looks like 43. You got to put the times in there. Okay, so just be careful. Okay, so that's the distributive property. Say homework 1-8. Is that you had a question on, Emily? Do you remember which number?
I'm trying to.
Okay. Find the right one, yeah, homework 1-8. You think it was 1.7? Okay. Let's take a look at 1.7. And what was the problem type again?
It was like there was a shape and it was like cut in half.
Okay.
And you had sides that were missing.
Okay. Oh yeah, that could have been in the fixer-upper, yep. We had some formulas to work on there. Oops, wrong button. Let's go to the next one. Okay, so shapes cut up. So this one you're supposed to name the formula. So not that one, right?
I think it was like 8
or 9.
Yeah.
Okay. So you want to come up with the area and the perimeter here. All right, so let me copy this into my notebook, and we'll pick it apart. Okay, so some things to note. They don't give me all of the dimensions. So for example, what do I know so far? Well, I know this side for sure. I know this side for sure. I know that one, and I know this one. So somehow I got to be able to backtrack and figure out what the other ones are. So for example, thinking about this one right there, well, I know to get across to there, it's 4.7. And total to get all the way across, it's 9.3. So then what do you think I should do to find that difference right there?
Subtract 4.7.
Yeah, subtract. Yeah. So that one right there is going to be the 9.3 minus the 4.7. So pulling that off, we'll have to borrow. What is that? A 6 coming down. And then, so it looks like this right here ought to be 4.6 meters. Double checking. 4 and 4 is 8. 0.7 and 0.7 would be 1.3. 8 and 1.3, yeah, 9.3.
Figure out like that one you was.
It would be a subtraction too. Yeah, take this partial side over here, subtract it from the whole side there, and the difference has to be that. So 9.5 minus 4.5, I think, what would that be, 5 on a good day? So that length right there should be 5 meters. So now I can definitely do the perimeter by just adding up all the sides going around there. There's 2 ways to do the area here. One way is to just break this into 2 different rooms. So this room right here would be the 9.3 times 4.5. What would be the dimensions of this upper room here?
4.7 times 5.
4.7 times 5, yeah. So 4.7 times 5, and then add those 2 results up to get the total area on that one. The other way to look at the area, let's copy that to a new screen, would be to consider this a bigger rectangle. That's 9.5 by 9.3. And then you could subtract off that part, and that part would be 5 by, what do we say, 4.6. So I could calculate the big area and then subtract off the smaller area.
and that'll give me what's left. It should work out the same way.
So I thought for some reason I did it a couple different ways.
It didn't work out? Yeah, so let me double check that right there.
Bring up that one.
Calculator. So 9.5 times 9.3, take away 4.6 times 5. So the first time through, I tried taking the big area and subtracting that little one off, and I got 65.35. So make a note of that. If I try the other way, I have two different areas to add up. So doing it the other way, what do we have? We have 9.3 times 4.5. And you guys might each have slightly different numbers on this one. I can't remember how I set it up.
Yeah.
Plus 4.7 times 5. And hopefully I get that same result. Oops, show me the calculator. Shoot, can't see you. All right, blow it up. 65.35, yeah, so I get the same answer either way. So you just must have had a slight mistype in the
So how
calculation.
did you get the, oh wait, no, that one's fine. So you do-
And this is going to be square meters or meters squared. Yeah, so this section, I'm doing the big section down here, and that's 9.3 across and 4.5 tall. And then this one right here is 4.7 across and 5 tall. So I had to multiply, multiply, and then add those results together to get the full area. And so notice, on a lot of these problems, I got to write it down to do it, right? We can't just look at the screen and get an answer unless you're a super genius, which I am not. All right, we are going to play more with percentages. So we're going to take a look at worksheet 9. And I think I printed some for those of you here. Here we go. Okay. All right, let's get it up on the screen here. New page here. Worksheet here. It's 1 8, 9. So 1.9 picks up where lesson 1.8 left off, playing around with percentages. Here, we're going to play around with credit card debt, which if you don't have yet, you might someday in the future, but it's a good thing to avoid. Credit card rates vary all over the place. So let's suppose in the mail, you got a credit card offer, and if you look at the bottom of page 1 here on our sheet, that offer, when you apply, you'll get a percentage rate somewhere between 10.99%, so about 11%, and 23.99%. So unless this is like a first-time credit thing for you to kind of build credit, highly avoid 24% interest rate. And if you do, do not get an accumulated balance there, because it is very hard to get rid of at that high a rate. That's a lot of money. And we're just going to kind of play around with this. So this is interesting. According to the Federal Reserve, in 2015, Americans had a debt of about $800 billion combined in the United States. So the average amount of debt that people have in the US has been rising over the years. 20, 30 years ago, people had very little credit card debt. These days, people have a lot of credit card debt. And so that's an interesting thing for our economy and personally for individuals. It's something to think hard about. So we're just going to kind of play around. Annual percentage rate varies with the market based on prime rates. Okay.
So one thing you're going to look up is what is a prime rate. We'll come back to that. So, and then we're just going to kind of play around with these numbers here. So what does APR mean? There's an idea called credit worthiness. There's credit scores that different companies dish out, and there's a bunch of different credit companies out there that monitor in the credit of individuals, and then companies that might loan you money, check with them to see what your credit score is. And credit score is affected by a lot of different things. So some things that we need to be familiar with. We'll see the abbreviation APR come up a lot. And APR stands for annual percentage rate. So generally, whether you're going to go for a credit card or a car loan or a house loan, they usually talk about the APR, the annual percentage rate, and that's the rate that applies for a year. So let's suppose you had really good credit, you had a very high credit score, then you're going to end up with something like an 11% rate. So good credit. Oops. You might end up with 11 or 12% on initial credit card. So remember, 11% as a decimal is 11 hundredths, because percent means divide by 100. Often when debts are calculated and the amount of interest due, right? So again, this is an interest rate. Interest rate. We generally use the decimal version to calculate an interest amount. So versus interest amounts. So the interest amount is where we have some kind of debt. So let's suppose that we had $100 on our balance. The interest amount would be to take 11% of that, in which case we would get $11 for the interest amount. Right, so we have percentages we're going to deal with. We have amounts that we're going to deal with respect to that. Now, important thing about this 11% here, it's an annual percentage rate. So if that $100 sat in debt for a whole year, then you would owe the amount of $11. Okay, do people and banks usually let you have that money sit for a whole year? Answer is no. Usually what happens is we have to do some kind of monthly payment. So we have a slight discrepancy between a yearly rate versus a month has just gone by. So what's a fair way to deal with that $11 that you quote owe if the whole year hasn't gone by? Only 1 month has. There's a couple ways we can deal with it. Anyone want to make a suggestion? Yeah, divided by 12, because there's 12 months in a year. So 12 months equals 1 year. So if we have $100 in debt for 1 month at 11% APR, then we would take our $100, we would multiply it by the 11%, and then you could either say multiply by 1/12 or divide by 12. I'm going to call it multiply by 1/12 here, because this is an idea that's called simple interest. Okay. So with simple interest, you just take the amount. Sometimes that's called the principal. I'm going to call it P. And you multiply by the rate, and then you multiply by the amount of time that's gone by. Okay. So you might have seen the formula before, I equals PRT. P stands for principal. It's just the amount of money you're starting off with. So principal can also be called a balance.
Now looks like too many L's for balance. So principal times rate times time. The key things here, the rate and the time have to have the same time units. So if the rate is given annually, the time has to be given annually. If the rate is given as a monthly rate, the time has to be monthly. What if it's a daily rate? Time would have to be days. Yeah, so we would divide by 365. And a lot of credit card statements, if you look at them, they talk about an average daily balance, right? Because that's kind of how they figure out what you owe them in terms of interest over time, the average daily balance. So the longer over a month the money has been owed, the more interest you owe on it. Whereas if you just bought something at the end of the month, the less interest you owe on it, okay? So it's kind of complicated, but it's really based on the idea of simple interest, okay? So we always have to be conscious of that. So for us right here, after a month on that $100, we don't owe $11, we owe 1/12 of that $11. And that's when things get messy. There's my calculator, there we go. So clear this, so take 100, see, multiply by 0.11, and then divide by 12. So I come out with 91.666666 cents. Okay. Now, banks have a couple of options when they're dealing with fractions like that. They can round it up, saying you owe us 92 cents this month, or they can just chop off that 0.66666 cents and just say it's 91 cents. And again, they can do that however they want. They're going to do that to benefit them. So if you owe them, they're going to call it 92 cents. If they owe you, they can call it 91 cents. Sorry to say. Okay. And if you ask, they have to disclose how they do these calculations. Other things that are kind of tricky in terms of lending, if you're really interested in this, there's a law called the Federal Truth in Lending Act. It's been around for a long time and been modified over time. But how many days are in a year? Yeah. There are 365. Banks, however, can use any whole number between 360 and 365, depending on what suits them. So bank days can't be greater than 365, but they can go all the way down to 360. And usually they use 360 or 365. It just kind of depends. Right? And think about it this way. About how many days are in a month? About 30 days in a month. And how many months in a year? 12. And 360 is 12 times 30. Right? Okay. So there's different ways to think about that. Usually when they're doing calculations on credit card statements, they calculate an average daily balance for you, and then they figure out how many days are in that month. Was it 30? Was it 31? Was it 28? Okay. We're going to kind of keep it simple, and usually we'll go with something like 1/12 for months, and if we're talking about days, we'll use 365, but in reality, those numbers can vary. But the bank always has to disclose how they do those calculations if you ask to read that fine print, which is very exciting to read. All right, we are about out of time for fun with math. So your goal is to, let's take a look at this here. We need to finish up Unit 1 this week. We're going to have an exam. I'm going to move the exam to the 26th, giving us another day to get ready. You need to finish up any homeworks and preps that you haven't. My hope is that you did the prep for 1.9 already, and you're finishing up the homework for 1.8. If that's not the case, get on those. If you need any help finishing up any lessons, homework, or preps, let me know, because that's going to be done by the end of this week. All right? So we'll work some more on lesson 1.9 tomorrow. And Daisy, hang on a second, don't disappear on me. Can you hear me?
Yeah.
So can you go to the Hermiston campus tomorrow?
Yes, I can.
Okay, cool. So I'm going to come to the Hermiston campus tomorrow. I'm going to broadcast from there. So we'll have a room for us. So if you just, when you come in, if you could just ask for me at the front desk, and they'll tell you what room I'll be in, because I'm not sure what the room number is yet.
Okay.
Okay. So I'm gonna be there by 9 o'clock, and then I'll broadcast class at 10.
and then I'll have a little time to stick around after. So if you have any questions and you have time before class, come see me. Otherwise, I'll see you at 10.
Okay.
All right, I'll see you tomorrow, Daisy.
Bye.
Bye.